Okay, can you hear me? Everyone? Everyone, can you hear?
Yes, Doctor.
All right. Because I'm afraid I got no internet connection here. All right. Thank you. So we will wait for some of your friends. Okay, they are still not signed in. Okay, for those who already inside this platform, okay, you can take your attendance. Okay, the password already been given at the first of the chat box. Okay, IWWV2L. All right. Now there are 44, 43 of you, 45. All right. So this is only a revision. Okay. Okay. Can you see the slide? Okay. All right. Okay. Thank you, Nisha. So you can have your attendance. Okay. The password already been given in the chat box. Okay. You can see at the top of your chat box, there is the attendance password. Okay. IWWV2L. You can take your attendance first. Okay. Okay. So it's now 10:06. Okay, we will start our revision session in 10:10. Okay. You can also ask your question either from your chat box or you can also ask through the voice. Okay. So that all your friends also can hear what you want to ask. Okay. Okay, we will try to wait for others. It's now 53, 52. Okay, 52%. Okay, another 1 minute. Okay, can we start now? If can, okay, because this is a very, very short lecture today. Okay, just a revision. I have been requested by Dr. Suzy just to make some revision for you for your task 3. Okay, for your Hazid and Hazop analysis. Okay, so it's only 40 marks. Okay, from your total of your task 3 plan design. So siapa tak ingat lagi dah Hazid and Hazop? Kita nak test kat sini. Alright. Okay. Okay, we start now. Alright. Okay, Assalamualaikum. Good morning, everybody. Okay, today we will look for a revision of Hazid and Hazop analysis. Okay, some revision from your EKC 367. What is Hazid and what is Hazop analysis? Okay, so your task 3 EKC 453 plan design need you to make some analysis for your plan. Okay, you need to make your Hazid and Hazop analysis for your plan. Okay, so now we will look what is the revision. Okay, we just try to revise what is Hazid and Hazop analysis. Okay, not a fresh start or fresh lecture on Hazid and Hazop. Okay, just a revision. Okay, so most of you, I think, already remember. Okay, you remembered what is Hazid and Hazop analysis. All right, so we will start. Okay, okay. So the objective for today is to enable you to perform Hazid and Hazop analysis for major unit operation. Okay, for your EKC 453, there are two tasks. Okay, for Hazid and Hazop to perform the Hazop analysis for reactor. Okay, the first one is for reactor, and the second one is for distillation column. Okay, as far as I know, some of groups there are not utilize any distillation column. Okay, so their task is to perform Hazid and Hazop analysis for reactor and also their major separator unit. Okay, so basically, Hazid and Hazop analysis is for reactor, distillation column, or separator units. Okay, it's either two of these. Okay, so you need to able to make the Hazop analysis through this major unit operation. All right. So what is Hazid? Okay, Hazid and Hazop. Okay, there are two different things. One is Hazid. What is Hazid? It is hazard identification. Yeah, if you remember, this is, I think, the slide also the one that I use to teach you in EKC 367. Okay, Hazid is hazard identification, while Hazop is hazard operability. Okay, hazard identification first. What is hazard? Okay, hazard is observing unsurface condition and unsurface acts that potentially cause accident. So hazard or hazard analysis can be done through conducting walkthrough surveys, audits, checklists, and inspection. Okay, hazard analysis also can be done through safety analysis and also safety review. Okay, so through the examining documents and data, you can analyze the plant or the workplace for any hazard. Okay, or any hazard identification. So basically, hazard is inside hazard. Okay, hazard is inside the hazard. Okay, because hazard identification or hazard, they could also can be done through audits, checklists, and so on. Okay, but one of the tools for hazard is Hazop. Okay, I hope you clear. You can understand what's the difference between hazard and Hazop. Okay, just a revision. Okay, this is the example of what? Anyone can answer. This is the example of what? What is it? What the picture show? Okay, anyone? Can you answer? Give your answer. What is this? Okay, good. Okay, Jin Kyong. This is a checklist. Okay, this is a safety checklist. Okay, so checklist is one of the hazard analysis. Okay, uh, okay, this is hazard checklist. Okay, so you could identify hazard from your checklist. Okay, so you can start, okay, your plan design first through your checklist. Okay, you can make your own checklist, and then after your checklist, then you can go further for your Hazop. Okay, because checklist is not very comprehensive enough. Okay, it's not very comprehensive enough to cover all of your plan. Okay, as you can see, there are only for buildings, process, general layout, and so on. Okay, it covers a major part, but in a very not so detailed. Okay, it's not going deep enough for every unit operation. Okay, as you can see, it only focus on process, equipment, and so on. Okay, venting, instrument and electrical equipment. Okay, but it only cover the surface of these items. Okay, so basically your surveys or your checklist can be done as a first step during your hazard analysis. All right. Okay, this is another checklist. Okay, but have been built inside the software. All right. Okay, then you have your hazard surveys. Okay, you can also make your hazard analysis through surveys. Okay, previously is through checklist. Then you can also have your hazard surveys as your hazard analysis. Okay, all the surveys can be done through a form. Okay, there is a form for fire and explosion index and also chemical exposure index. Okay, you have your fire and explosion index and also chemical exposure index. Through the surveys, you will get your initial or your hazard identification for that process or for that equipment. Okay, we will see what's the example of the surveys. Okay, this is the step for your surveys. Okay, a very brief step for your surveys, how you break your process into units, okay, or section. So for example, reactor, storage tank, or pump. So in your task EKC 453, you already been given only 2 units. Okay, you only need to do your Hazop and Hazid analysis of 2 units. Only your reactor and also your distillation column. Okay, so basically the first part already been done for you. Okay, to break down process down, to break the process down into units. Okay, so you only have 2 units, reactor units and also distillation units. Okay, then you use the experience or your knowledge to select the units or section that have the highest likelihood of significant hazard. Okay, so this also already been done because we already just select 2 units. Okay, you only select reactor and also distillation column. Okay, so we have the assumption that these 2 units, okay, or these 2 major unit operation equipment have the highest likelihood of a significant hazard. Okay, then through this unit you define your material factor. Okay, what is the chemical being used in general. So then you adjust it with penalties. Okay, for surveys, you know that there are involved penalties and credits. Okay, so then you got your rates. Okay, you index. Okay, you will get your index for that hazard. Okay, we will see the example. Okay, this is the example for fire and explosion index survey. Okay, so this is your hazard analysis for maybe for your reactor or your column. Okay, so through your column or your reactor, you identify what's the material factor, the general process hazard factor, and also the special process hazard factor. Okay, you follow through all the form. Okay, what's their penalties and what's their credit for. Then you got your fire and explosion index here. Okay, F3 times your material factor. So that's it. That's the hazard. Okay, that's the hazard analysis. The very brief, okay, or brief analysis to identify your hazard. Okay, this is hazard analysis. Okay, are you okay with that? Hazard analysis. So it's up to you. Either you want to use surveys, reviews, okay, for your analysis, for your hazard analysis. Okay, through your index, you can determine what's the degree of hazard. Okay, what is the degree of hazard for your equipments or for your units, okay, for your reactor and for your column. Okay, this is the example you can look through. Okay, the same with your textbook example, how they identify the index of fire and explosion. All right. Okay, now we will look for the second part, Hazop. This is where the main part, okay, for your reports. Okay, the Hazop for your plan. Okay, so previously hazard identification. Now you have your hazard and operability, Hazop. Okay, so Hazop analysis is a formal procedure to identify hazards in chemical process facility. In your case, is to identify hazard in your chemical process facility in concern to the reactor and also distillation column. Okay, okay. Hazard have been applied and implemented in industries. Okay, the basic idea is to consider all possible ways. Okay, that's why we say that hazard is much more comprehensive as compared to surveys and also checklists because it try to consider all the possible ways the process and operational failures can occur. Okay, so this is the requirements before you can conduct your hazard. Okay, by the way, all these requirements I think already been fulfilled by all of you. You have your PFDs, you have your PNIDs, all the detailed equipment specification, you already design it. Okay, the material of construction already been specified, and also you already done your mass and energy balance. Okay, I think all of I think the checklist already been done. So you have all the requirements, and now you just need uh, to conduct your hazard. All right. So for a specific piece of equipment, okay, for in this case is a reactor and column, you will suggest a various event, okay. Then you need to determine the event occurrence. You also need to determine how the event could occur, okay, and also you need to determine what is the event level of risk, okay. This is the output from your hazard analysis. Okay, this is the output from your hazard analysis. Okay, this output is coming up from your equipments, which is your reactor and your column or your separator. All right. Okay. Bear in mind, okay, along when you are conducting your hazard analysis, there is some possibilities that your reactor or your column could be operate in transient operation. Okay, what is transient operation? It is the transition phase. Okay, means there are unplanned or very infrequent operation. Okay, but that operation or that operation are still being delivered, okay, during the process. Okay, for example, the one there are two scenario, okay, that you may need to consider during your hazard analysis. Okay, the first one is that when there is a non-routine operation or planned operation that infrequently occur. Okay, there are some operation that that is a non-routine. Okay, routine means every time every day they are going for the same circle. Okay, same cycles. Okay, but there are some operation that is non-routine. It coming up now and then. Okay, sometimes okay the operation needs to be done. Okay, such events include startup of major unit, including a total shutdown, operating with a non-standard equipment configuration. Okay, so for your reactor and your distillation column, at least try to include your Hazop analysis during your startup, okay, and shutdown. Okay, you also may include the analysis during the transition when the unique or unusual feedstock or grade changes. Okay, when you are trying to change your quality or so on. Okay, but as far as I concerned, that you still need to deliver your heads-up analysis for a shutdown and startup of your reactor and also distillation column. Okay, because every unit operation must have their shutdown, must have their startup or shutdown. All right. Okay, the second one is abnormal or unplanned operation. Okay, this is basically only for something that relate, okay, to the safety, health, and environmental issues. Okay, so the second one, if you have your scenario where there is a reactor runway or abnormal equipment configuration, you can include it, but as long as you have your startup and also your shutdown transient operation, then it is okay for you to have your hazard analysis. Okay, so remember, your hazard analysis not just include your notes, okay, but also to include all the transient operation. Okay, so I already make a summary for you for your hazard procedures. First, select a unit for study. So this is already been done. Okay, you already select your reactor and your column or your separator. Okay, so reactor, column, or separator. Then you need to choose a study node. Okay, what's your study node or your location of study? After you have your study node, okay, I think for you to make this hazard procedures very thorough, okay, you can have your units. Okay, for example, you have your reactor, then try to identify as many as possible your study nodes. Okay, list out all these study nodes. Okay, then from that study node, try to describe the design intent for each of the part. Okay, let's say if your reactor have 6 or 7 study nodes, then try to describe each study node, what is their design intent for. What is the intention you design that particular reactor, or what is the what is it mean by intent? What is the function? Okay, what is the function of that node? Okay, or that part? Okay, then you can have your process parameters along with your guide word. Okay, so Hazop basically it's just about node, parameters, and guide word. Okay, you have your node, you can have your parameters, then you can pair it with the guide words. Okay, then this come for your analysis. The analysis come when you need to determine the possible causes, any protective system, the consequences, and also what is the recommended action. Okay, all this information will be recorded in table form. All right, so basically that is hazard procedures. Okay, you try to identify because you already have your units, okay, reactor and distillation column. So you just need to identify your nodes. When you have your nodes, you have your design intention. Then you can proceed with your parameters and guide words. Okay, here you have your parameters and guide word. You will have your deviation. Okay, so this deviation will determine the possible causes and protective system. Okay, you try to evaluate the consequences and also recommend the action need to be taken to prevent, okay, from uh, the event from occur. Okay, just a very straightforward step. Okay, this one is only repeat, repeat, repeat. Okay, it's like a loop. Okay, just repeat all the guide words. Habis semua guide words tu, then pilih pula parameters baru. Okay, you choose another parameters. Then going back, buat balik sama balik all the guide words, and then patah balik. Habis semua parameters, untuk semua all the guide words, you study all the notes. Okay, just repeat back. Okay, all over and over again. Okay, so that's a very comprehensive analysis for an equipment. Okay, for your reactor and your distillation column, if you're going through all these steps, you will have a list of possible events. Okay, possible events that could be occurred in your process. Okay. Okay, this is the study notes. Okay, this is the tips. Okay, how you select your study notes. Okay, study notes usually come from vessels. Okay, the major process vessel. Okay, bekas dia tu. Then the process lines, all the connecting lines. So that's why we need your PNID and also your PFD. Okay, from your PNID you will have all these information. You have your vessel, you have your process lines connecting, okay, and then you have your pumps and compressor and so on. Okay, all these are study notes. Okay, it could contribute to your analysis. Okay, the less notes you choose, the less information or the less uh, ideas of possible events that you can extract. Okay, so if you have your as much as study notes that you can have, then you will have a list of possible event. All right. So power process parameters is just as usual. You have your flow level, temperature, pressure, volume, concentration, and so on. Okay, agitation for your stirrer, pH, and so on. Then guide words. Okay, this guide word will determine the deviation from your design. Okay, so you need to have some basic chemical engineering knowledge, okay, to determine what's the best deviation or what is the function words for these guide words, okay, because some combination of these guide words with the previous parameter, okay, will not give any meanings, okay. Then finally you try to evaluate what to determine what is the typical causes of these deviations. Okay, once the deviation is okay, then you try to find what is the causes. Okay, try to determine all the causes for this deviation. Okay, this one also need to be uh, going through. Okay, you need to be as detailed as possible. Okay, because this detail will determine what is the recommended action or what's the action that need to be taken to prevent, okay, from that event from occur. Okay, so the causes could be from your hardware failures, from your human error, your operator's error, the outside forces, and also unanticipated process states, okay, from your process. Okay, this is some example of your guide words. Okay, all your guide words. Temperature. All right. This is the example of your Hazop example worksheet. Okay, I think all of you already seen and you already done your uh, integrated design. If you look back all your integrated design answer during your third year, you have all these Hazop example or your Hazop studies. Okay, you already done your Hazop analysis during your integrated design. All right, it's up to you. What type of form that you uh, what type of form that you want to utilize. Okay, it's up to you. As long as you have all this information, what is the study note, what is the process parameters, the deviation, the possible causes, possible consequences, action required. Okay, and also the recommendation action if there is any. Okay, this table have been done in Excel. Okay, it's been developed in Excel. As you can see, this is for node 1. Okay, for a specific equipment. Then it can also have node 2, 3, 4, and 5. Okay, so there is their parameters and also the deviation. Okay, so your job is to try to find what is the cause, consequence, the safeguard, and the recommendation for this deviation. Okay, more flow or less flow or no flow. Okay, what is the causes of it? All right. Then, okay, this is the example. Okay, I don't want to go detail with you. Okay, this is the example of the reactor. Okay, uh, the one that I've circled is one of the node that I choose. Okay, we have the reactor units. Okay, this is your unit reactor. Okay, this is the reactor, your unit. Okay, the second step is to select the node. Okay, but I said to you that maybe you can try to list out first what is the nodes that involve inside the unit. Okay, so the reactor unit, I already highlight one of the node, okay, which is involve the vessel itself. Okay, this is the vessel itself, the cooling coils. Okay, now I need your input. Okay, what another nodes that involve in this unit. Okay, siapa boleh bagi? Cakap pun boleh, tulis pun boleh. Alright. Sebab dah habis dah. Okay, kita punya lecture dah habis sampai Hazop saja. Okay, Hazid and Hazop, just a revision. So that's why Dr. Suzy said to me, just less than 1 hour, try to finish it. Okay, just a revision for you. Okay, nak ingat balik what is Hazid, what is Hazop. Okay, so kita buat balik step kita. Okay, step 1, identify the units. Okay, we already identify reactor. Okay, maybe kalau awak ada column, okay, column. Okay, awak ada picture column. Okay, distillation column. So, second step is to find the node. Okay, tapi kalau nak cari node satu, lepas tu buat balik, nanti nak patah balik, cari lagi node, lambat. Okay, try to find first. What's your node? Okay, mana lagi possible nodes inside your reactor? Siapa boleh bagi jawapan? Mana lagi notes yang ada? Cakap lah, cakap. Kalau tulis lagi, nak terangkan tu tak nampak. Anyone? Dengar suara dah tu. Siapa dia tu? Saya pun tak. Anyone want to try? Saya tak bawa saya punya wheel of fortune ni. Kalau saya boleh copy. Okey, semua nak tulis je, tak mau dengar suara. Alamak. Saya tengok satu-satu balik. Lepas dah ni. Tio kata process stream. Yogi kata motor. Karya kata propeller. Okey, propeller dengan motor. Okey, same thing. Okey, monomer wafid. Lagi thermocouple. Shy cat. Killer wheel. Okey. Ada lagi tak? Okey, kita tengok ada pen tak sini. Pen. Okay. So tadi kita tengok balik. Process stream. Process stream yang mana? Theo. You need to clearly identify or clearly state which one. Okay, which one is your nodes. Okay. Okay, the first one kita buat tadi cooling coils. This is your nodes. Okay. Okay, lepas tu Yoki dengan dia kata motor or propeller. Okay. This one. Okay. So, this one inside the vessel, but it also have their own function. So, this one also can be your node. Okay. So, motor or propeller can be your node. Okay. Then, Nerusha kata monomer feed valve. This one. Alright. So, ingat tak tadi? The first one kita tengok dalam vessel. Okay, so vessel already been covered. You have your cooling coils. You have your propeller or your motor. So, habis. This is your vessel. Then, going for your piping. Okay, or your connecting lines. The first one, connecting line is monomer feed. Good. Okay, this one also is your nodes. Okay. Then Zaidatul kata thermocouple. Okay. Okay, monomer feed. Okay. Then thermocouple. Thermocouple is the one actually. Okay. Okay, ni dia tak ada line itu. Okay. Thermocouple is the system. Okay. This is the control system. Thermocouple and your controller is your control system. Okay. Even though it has a function, but the function is not involved in the reactor. Okay. So you have your feed, cooling coils, motor. Ada lagi tak? Ada lagi satu. Siapa boleh bagi lagi satu? Anyone? There is cooling water out valve. Okay. Lagi? Siapa lagi nak try? Cooling water inlet. Okay. Cooling water inlet, cooling water outlet. Okay. Since this connecting line is involved cooling water in and out, we can make it as one of a node or you can make it as a separate. Okay, so both answers are correct. Okay, cooling water out and cooling water in is another nodes. Okay, you can treat it as different nodes. Okay, one nodes in and one nodes of out, or you can include these two, then you regard it as a node of cooling water stream. Okay, as a cooling water stream is either inlet or outlet. But if you make it as a separate, one is cooling water out, one is cooling water in, then you have more specific analysis. Okay, it will involve very specific analysis. Okay, because you will study all the way down in water out first. What happened to water out? Why is less flow, no flow, overflow for your cooling water out? Then you concentrate on cooling inlet of cooling water. What happened to this inlet cooling water? So this inlet cooling water will also be determined by this. Okay, the causes for the event will be contributed by this control system. Okay, so if you can identify as many as possible all your nodes, then you have very impressive analysis or Hazop analysis. Okay, okay, so after you done all your node selection, then you try to describe what is the function of these nodes. For example, cooling coil. What is what is the function of this cooling coil? Okay, then you go for your motor. What is the function of this motor? For mixture, for stirrer, and so on. Okay, then you can identify what's the possible event that could be occur when these go deviate from the normal. Okay, so you have your nodes done, you have your design intention done. Okay, now you just need to choose your parameters, okay, and your guide words. Okay, this is your parameters and your guide words. Okay, the combination of these parameters and guide words will help you to determine what is the possible causes, possible consequences, and also the action required, okay, to prevent all these incident from occur. Okay, as you can see, the possible consequences or the possible causes could be sometimes can be repetitive. It's okay. Okay, it can be repetitive. It's okay since some the same causes can contribute to different type of incident. Okay. Next. Okay. The last part after you have done your Hazop study, now this is your Hazop analysis. Okay. This is the Hazop analysis. Okay, you need to include all of this inside your report. Okay, what is your Hazop analysis? Is your findings. Okay, what is your findings after you have done your tabulation? Okay, after you have table out all the possible causes, consequences, and action required. So, what is your findings? Okay, what is your conclusion? What is your summarize from your analysis? Okay, so from your Hazop study, you can summarize. Okay, for example, in here, you need to install high temperature alarm. Okay, for why? Okay, why you need to install the high temperature alarm? So you need to install high temperature shutdown system. Shutdown temperature system should be higher. Okay, all of these are the summarize or the conclusion from your Hazop study. Okay, so you done your Hazop study, then you make your analysis. Okay, so this is your Hazop analysis. Okay, so Hazop analysis is your conclusion, your summarize, uh, your summary. Okay, for your Hazop studies. Okay, you need to install a check valve. All these are recommendation or modification to your plant, okay, in order to prevent from any other incident. Okay. Okay, there are a lot of analysis here. Okay. Okay, this is for heat exchanger. Never mind. Okay. Okay. The same for, like example, for heat exchanger. Okay, heat exchanger does not include in your EKC 453 task, but just first focus on the vessel itself, inside the heat exchanger. Okay, about the piping and so on. Okay, then concentrate or select your nodes based on the connecting lines. Okay, for that vessel. Okay, so you will have your volatile solvent, condensate line, your steam line, okay, and so on. All right. Okay, that's all. Okay. Any question? Any question? Ada siapa-siapa nak tanya regarding your task uh, or anything regarding the Hazid and Hazop? Okay, okay. Okay, kita tak ada. No. Yang lain ada tak? Uh, come on, before we ended our class. Sekejap. I have something to share with you. Okay, if you can wait for a while, I'll try to find some information. So, alright. Okay, sekejap ya. Okay, can you see the one that I've shared with you about the Amazon Web Services, about the cloud foundation? Okay, so for those yang ada masa lapang, okay, just I want to promote to you, okay, siapa yang ada masa lapang, you can register to this Cloud Academy, okay. This is the foundation, okay, the very basic step to introduce you to the AI, okay, AI and machine learning, okay. Yang dia just for application, okay, it's just for application, okay. For those yang berminat, okay, interested to include in your CV about your experience in AI, okay, there is a collaboration between USM and Amazon Web Services. Okay, we introduce a free online learning for cloud foundations. Okay, during this cloud foundation, this only take around 20 hours of lecture and also uh, some work to do, but it's on your uh, just for your self learning means that you can choose any time that you want to learn. Okay, just complete the 20 hours of lecture, then you can take your exam. Okay, there is a mocking exam price for $20, 20 USD dollars, but for USM students and staff, there is a free of charge of mocking exam. So you can test your knowledge there. If you are confident enough, okay, to take the real test, okay, from 100 US dollar, it's been discounted. So just for $50, okay, 50 USD, you can take the exam for the cloud foundations and you can be certified by Amazon itself as a cloud practitioners. Okay, so during your uh, w- uh, w- during your job hunting, okay, you can put it in your CV as a cloud practitioners. Okay, because nowadays all the smart manufacturing using cloud. Okay, every smart manufacturing including will involve cloud services. Okay, so you will have your tag as a cloud practitioners by Amazon. Okay, this is a collaboration. Okay, the first collaboration between USM and Amazon. Okay, to provide some knowledge. Okay, and online learning for all the student and staff. Okay, the enrollment is free of charge. Okay, you just need to complete all your lecture notes, your lecture videos, and your tasks only in 20 hours. Okay, so those who are interested, okay, I will post also this poster, okay, inside the notes that I will given to you and also the videos for today's lecture. Okay, so thank you for your attention. Okay, those who are okay, those who are interested, you can enroll to this class. Okay, free of charge. Nothing can harm you. Okay, just try to enrich your information and enrichment knowledge towards the AI and machine learning. All right. Okay. So 50 for Magellan, you 50 US dollars is for the real test to get the uh, as a cloud practitioners. Okay, to be certified as a cloud practitioners. Okay, after that there will be a more step. Okay, you can be a cloud designer, cloud architecture, and finally you can be the cloud I think the experts. Okay, the expert for the cloud computing. Okay, so far so good. You just take the class, and then if you don't want to take your exam, it is okay. So you still have the knowledge of the cloud foundation. Okay, so thank you everyone. Okay, it's already 11 a.m. Okay, thank you for participation. Okay, don't forget to sign in your attendance. For those yang ada masalah untuk attendance, okay, you can email me. Okay, if you have any difficulties in signing up your attendance. Okay, by then, thank you. Thank you for your time. Thank you for your concentration. I will upload all these notes and videos later in this evening. All right. Thank you. Thank you for listening. All right.